told you to come in and switch the other two.
Okay. I agree. Just switch the chair around. No one will ever know.
Or just don't move like
Okay. So, example 3. I'm going to start while he's doing that. They give us some C values. For C equals -3, 3, and 7. They're asking us to find f of C. They're asking us to find the limit as x approaches C from the left, and the limit as x approaches C from the right, and the limit as x approaches C. And then justify your findings using 3-part definition of continuity. Okay? So, let's start with C equals -3. And let's go through and find these pieces of information and then go from there. I'm trying to look and see. Okay, so what do we know at C equals -3?
Equals 2.
Okay, so if I say what is f of -3, what are you going to tell me?
2.
Because that is where the point is, yes? Okay. What is the limit as x approaches -3 from the left of f of x? You guys good with that?
Yeah.
And then the limit as x approaches -3 from the right of f of x is -1 as well. So what does that mean about the limit as x approaches -3 in general? It is what? -1. Now, we found all the pieces required. Justify your findings using a 3-part definition of continuity. Basically, what you're trying to tell me is this graph continuous at x equals -3?
No.
No, because?
There is a removable discordant.
Okay, what's my limit definition say?
If the equal from the left and from the right,
Well, left and the right and
it has the, yeah.
at the point, yes? So here, basically, the limit has to equal the value at the point. We give the left and the right, so we know the limit. But my limit has to equal my point. And so, let's see, how do I want to write this? I'm going to say, excuse me, at x equals -3, not continuous, because, not continuous,
Because limit x approaches -3 x does not equal f of x.
and limit as x approaches -3 of f of x does not equal f of -3. So limit as x approaches that c value does not equal f evaluated at that c value. And I guess what I really should have said here, f is not continuous, is what I really should have been saying. But in easy terms, it's not continuous because there was a hole, right? In calc official terms, using the definition of continuity, it's not continuous because the limit does not equal the value at that point. That's officially what we have to say. Okay? Let's try another one. C equals +3? What do you know at C equals +3?
There's an asymptote.
Okay. So again, using the definition here, what is f of 3?
Infinity?
D and E.
There is no value at when x equals 3.
Oh.
The graph has no value there, so it does not exist. What's the limit as x approaches 3 from the left of f of x?
Infinity.
Pause infinity. What's the limit as x approaches 3 from the right of f of x? So what's the limit as x approaches 3 of f of x? Now, okay. Continuity-wise, yeah, at x equals 3, f is not continuous because the limit as x approaches 3 of f of x is not equal to f of 3. Now, can I fit the other one in beside it, or do I need to go? Yeah, we're going to make it work. What are we doing? 7. So, f of 7. What is f of 7?
3.
Agreed?
Mm-hmm.
Okay. The limit as x approaches 7 from the left. 3. The limit as x approaches 7 from the right.
6.
Up here. 6. As we approach 7 from the right, that means you're tracing in here. It doesn't matter where the dot is filled in, it's where is the graph connecting.
I didn't see it.
Okay? Okay. That's all right. It's just easier. Let me get that question answered right then, right? So the limit as, what did I do? I stopped to answer Hannah's question there in the middle, and I have an extra limit in here. Yeesh. Come on. Okay, the limit as x approaches 7 of f of x
Unity.
does not exist because the left and the right do not equal each other, right?
Mm-hmm.
So, what do we know at x equals 7?
F is not continuous.
F is not continuous.
Yeah, it's not continuous. The left and the right do not equal each other, which you could just say that is your reasoning. Because we couldn't even find the limit because the left and the right do not equal each other, or you can say what we've been saying on all the others. So, at x equals 7, f is not continuous. And you can say what we've been saying. The limit as x approaches 7 of f of x is not equal to f of 7. Or if you'd, yeah, that's what I thought. Or the other reason you could say is the limit as x approaches 7 from the left of f of x is not equal to the limit as x approaches 7 from the right of f of x. That would be a valid reasoning as well. Okay, so if you ever have to argue continuity, I know in layman's terms we just want to say, oh, there's a hole. Oh, there's an asymptote. But we have official.
Mr. Horn, please call 1165. Mr. Horn, please call 1165. Thank you.
Yes.
So what if we get f of x equals d and e, and then the limit as x approaches c of f of x equals d and e? Would that be
That would still be not continuous.
okay? So even though they equal each other,
Yeah. Well, here's the deal. If the limit doesn't exist, that means the left and the right weren't the same.
okay.
So that takes us back, because that's what happened right here, is that this would trump right there because the left and the right weren't equal to each other. That's the way you're going to get a limit not existing, is when your left and your right equal each other.
Okay.
Otherwise, your limit's going to exist somehow or another. Make sense?
Yeah.
Okay. Okay. And so, you must be able to confirm continuity without a graph or a calculator by using your knowledge of function behavior for parent functions and their transformations. So this is, okay, here they give us a kind of screwy graph, right? Going all over the place. This situation, they're going to give you a graph if they want to ask the questions. But as we look down at A and B, now they're going to give us more, okay, equations. And it's the idea of don't grab your calculator and just plug it in, but what do you know about that graph? Okay, so this goes back to that pre-calc, chapter 1, where, you know, we had all those graphs. I've been trying to encourage you to know what they look like and build on those. Same idea we're going with here. Okay, so in example 4, find the values of x where the function is discontinuous. Describe the type, infinite or removable, and justify your answer by using the definition of continuity.
Is there, for A, is there a vertical asymptote at 3?
Is there?
Yeah.
Okay. I didn't know if that was vertical. Horizontal is the one where it's like if there's an X on the.
You have to look at your coefficients, top and
Yeah.
bottom, like
Yeah.
highest powered coefficients, top or highest powered, I guess, top and bottom, and then decide from there. Okay, so discontinuities happen when the denominator equals 0 right there, yes? And so right there, what's already pointed out is, oh, x is not going to be able to equal, whoops, not -3, but +3, right? And is there an x minus 3 on top that can cancel?
No.
No. So we know that as a vertical asymptote is what you've been taught since Algebra 2, right?
Yeah.
Okay. Now, here's where I have to get a little more specific with you. We know the basics here, right? But now we have to extend it into calc knowledge because the directions say to justify using the definition of continuity. Okay? There being a vertical asymptote that's not justifying using a definition of continuity. So, I'm trying to think what the best way to think about this is. Which I will say, okay, is it infinite or removable? So if it's a vertical asymptote, what is that?
Infinite.
That is infinite, right? And weird, they combined. It's infinite. If your brains go back to the other one, it's non-removable, right? They didn't ask that, I know. But I keep trying to tie those together. So there's a couple of different things we could look at here. First of all, if we think about the point f of 3, what do you know about the point f of 3?
1/0.
It's 1/0. We already know there's going to be an asymptote there, yes? So the graph at 3, it does not exist, or I'm going to use the vocabulary undefined.
How do you go? 1/0.
Because you plug in.
3 minus 3 is 0.
Oh.
Just plugging it in. Not doing a limit or anything. They're just
Yeah, I'm like. what?
plugging it in to see that, oh, okay, f of 3, that value doesn't exist.
Okay.
And we're not doing limit, so I'm not going to try and argue it's infinity or negative infinity or anything like that. It just doesn't exist. Now, so right there, that being undefined, that's going to ruin the, our definition there of continuity. Okay? And I think if we go back, definition of continuity right there, we've killed it. Yeah, there we go. Because f of c is defined. What did we just find out?
F of C is undefined.
This is undefined. Okay, so right there, the fact that the limit must exist, the limit must equal that point, the point doesn't even exist. So right there, that's part of your definition of continuity. So, yeah, and I don't have a specific statement here listed necessarily, but one of those things would look at the problem. We could also look at left and right hand limits. Limit as x approaches 3 from the left of f of x, and the limit as x approaches 3 from the right of f of x. Okay, brain power here. If we take off the 3, and I just give you the graph, f of x is 1/x. It's one of your 12.
Yeah, because it would be like.
What? What was the question?
f of x equals 1 over x. That's one of your 12 graphs that we learned in pre-calc almost a year ago.
That's the V.
Nope.
No?
No, it's the
That's
half.
absolutely.
It's the what?
It isn't.
I don't know. You might be. I'm trying to figure out where you're going with
Because
that.
if
It's
you
not that
square
one.
it, to like square root it, wouldn't it be 1 over?
I don't know, it's kind of reminding me of y equals mx plus b, so I'm just gonna keep my mouth shut.
Or maybe I'm being stupid. I don't know.
That sounds like a nerd.
Yeah.
Yeah. That'll get you.
Okay. So
That
this is
makes
our
sense.
reciprocal function. It's also, we learned this graph in algebra 2, technically, too. Because we graphed it in algebra 2. But this is your reciprocal function. Now, think about this. This is 1 over x. What's that minus 3 do to it?
Scoots it over 3
To the left.
to
Right.
the right.
Oh yeah, 'cause it's opposite sign. Second line.
And so now, that means that asymptote just scooted over 3, yes?
Yeah.
So there's your graph. Now, can you answer those limits?
Negative 50 and
The limit as x approaches 3 from the left, that one's going to go down, so that's negative infinity. The limit as x approaches 3 from the right is going to go up, so that's positive infinity.
you also think if you do like 2.999 minus 3, it's going to give you a negative, and it's going to be a really big number.
So the other way to do this, okay, if your brain graph fails, you don't have access to your calculator right now, your brain graph just failed and didn't come up with this. Could we plug in things like 2.9999 and 3.0001? Yes, because if you plug in, so this is 3 from the left, so 2.999. Then you're doing 1 minus a negative 0.0001, or how, I've lost track of my 9s and 0s, but you get the idea. And if it goes even farther, then it's 1 divided by negative 0.000001. Well, as that number gets smaller in that denominator, that means my fraction is getting bigger, but in the negative direction, because it was going to be divided by a negative. Whereas this one, you do 3.00001, how many zeros, right? 3.001 minus 3, well now it's 1 divided by positive 0.0001. And then that is trending towards positive infinity. So yes, you can do it that way as well. Both are good. There are advantages to remembering your graph, but the other one works as well too. Okay? So, for all of these reasons, right here, f of 3 is undefined. That right there blows our continuity definition. And the fact that the limit as x approaches 3 from the left does not equal the limit as x approaches 3 from the right. Okay? Those two pieces right there both blow our continuity definition. So we didn't even get to the fact of, does the limit equal the point? Here you go, Doug. I have an undefined point, and technically an undefined, a point that does not exist and a limit that does not exist.
Okay.
But it's still not continuous. Is that the point from earlier that I was trying to make?
Yeah.
Okay. That point doesn't exist because it's on an asymptote. My limits didn't equal each other either, so. Okay. You ready for B?
Looks like a horizontal asymptote to be here.
It looks the greatest function.
Okay. More of our concern is going to be anything
That cancels.
Yeah.
going on in the denominator or whatever. So 2x squared plus 7x plus 6 over x plus 2. So we know there's something going on at x plus 2, right? So we know x cannot equal negative 2. Yes? Because I set my denominator equals 0. I know x cannot equal negative 2. What is it there? because they wanted to know, is it infinite or removable? Well, what do I need to check before I decide that?
That's the top factor.
The Topkin factor. Now, I'm not doing product of AC here. Use your brains with me, okay? The denominator is x plus 2, right?
Yes.
We're going to assume the numerator factors into 2. 2x squared, what does 2x squared have to break into? 2x and x. If anything's going to happen, this x is going to be an x plus 2. Now, is this definitely an x plus 2?
No.
No, but if something's going to happen of importance, I'm going to try this as an x plus 2. If this is an x plus 2, well, what do my values have to multiply to be? 6. So that means this is 2 and this is 3. Everything is positive, so positive. Now, can you do a quick mental FOIL on top to make sure it worked? 2x squared, 4x, 3x is 7x, and 6. Okay? I can't guarantee that x plus 2 would have been true on top, but it's a good, solid thing to check because it is likely. Okay, so now, because we have x plus 2 and x plus 2, that means that x equals negative 2 is a
Removable.
okay. It is a whole, which makes it a removable discontinuity, which is what they asked. I will also agree with it being a point discontinuity as well.
So do they call it removable because it's able to be taken out of the equation? Because that's what I've been trying to tie things to.
That works too.
That's what
I always think of it as removable because, like, I can take the point out and I can put the point back in.
That's what I was
It's weird, but it's just like how my brain remembers it. But I do think that that's you're removing the factor. That works too.
I'm just trying to track things.
I know, exactly.
This has been like really hard for me.
Yeah, you have to have a way to know which one's removable and non-removable, and not just okay in those couple of days we talk about it, but long term. You know, okay, we haven't talked about it since last year in pre-calc, but I need you to know it today. Or okay, we're going to talk about now, but now I need you to know it in April when we're reviewing for the calc test. You know, like all that. So, okay. With this in mind, how can I justify that this is not continuous? I'm trying to decide how I want to answer this myself.
There's a removable discontinuity.
Okay, there's a removable discontinuity. Can we look at the limits?
You can.
Yeah. I mean, there's that hole, so that also is going to, what am I doing? As x approaches what? Negative 2. And it's technically of g of x, not f of x, only because g of x is what was defined, right? So, and negative 2 from the right. And now, do you guys know how to graph this?
It's somewhat.
Yeah. This is a very easy graph. These x plus 2's canceled, yes?
Yeah.
What is this? What is this then?
Oh,
It's a line.
it's just, yeah.
It's just a line. It's a line that's going to have what?
A hole at negative 2.
So right here, here's my y-intercept. Rise 2, run 1, down 2, something like this, except this one over here that's at negative 2 is going to actually be I should have done that differently. This one's going to be a hole. So it's a line that has a hole right there. So in other words, if you have a factor that cancels, yeah, you can graph 2x plus 3 and just realize, oh, I have a hole there. Now, what's that say about the limit?
It's approaching negative 1.
In both cases? It's a line, yes? So that says the limit as x approaches negative 2 from the left is negative 1, and negative 2 from the right is negative 1. And you guys saw me, I just did the slope down to there, right?
Uh-huh.
Down 2, left 1, down 2, left 1. So right there, my limit does exist, but g of negative 2 Actually, I'm going to go put this underneath. What do we know about g of negative 2?
Undefined.
That is undefined. There's a hole there, right? Or it does not exist. So for right there, we could talk about the fact that the limit as x approaches negative 2 of g of x does not equal g of negative 2. We can go back to that statement. We can go back to the statement, there's two things that the limit does not equal the point, and the point is undefined. Those are both reasons that we can say, nope, definitely not continuous. Okay. That's the problem. There's only 2 more pages, but some of this takes a lot of writing. So, okay. So, we're going to look at 4a and b again. I think there's a typo in this section because we do number 4 twice. This is number 4, but we're going to do another number 4 now. Use the definition of continuity to find the value of k so that a function is continuous for all real numbers. Well, piecewise functions, right?
I love these things.
What do we have to think about here? Left and right, yes?
Yeah.
Because it's piecewise, we have a left and a right. So if we want this to be continuous, here, look at what we have. Kx squared. That's a parabola of some sort, yes?
Mm-hmm.
Continuous? Yeah. Kx minus 6. That's mx plus b. That's a line. That's continuous, yes? So what's the piece that matters? Where they connect. Do they connect at the same spot? And it is a filled-in point. So we're going to look at the limit from the left and the right. So the limit as x approaches, what's our key number?
2.
2, because that's where the piecewise is broken up. And I'll start with of the left. The limit as x approaches 2 from the left. Which value am I going to use there?
Kx squared.
Specifically, where x is less than or equal to 2, I'm going to use kx squared. Find that limit.
4k.
Okay, find that limit means I'm taking 2. Well, okay, so I didn't put g of x here because I wanted to specify which part of g of x I was using. I could have said g of x, but then I wanted to specify that I was using kx squared. Okay? G of x would be a valid statement.
Putting G of X in.
Yeah. The thing is, I would have then just rewritten it and had to put in the k of x, kx squared. So it would be true if you said g of x as well.
I'm a little confused why you use kx squared. Since it's on the right, it's greater than 2.
No, this is less than. This says where x is less than or equal to 2.
Oh, okay.
So I'm looking at this right here to decide. And so when x is less than or equal to 2, those are my numbers to the left of 2. Okay? Good?
Yeah.
Okay. Good? Okay. So now kx squared, as x approaches 2, that means I'm going to take 2 and plug it in for x. And so that is k times 2 squared, which is 4k. So the limit on the left is equal to 4k. Repeat the process for limit on the right. The limit as x approaches 2 from the right. So now from the right, I'm looking where values are greater than 2. And so that's using the equation kx minus 6. Again, I could say g of x right there, but I'm saving myself an extra step. So now the limit as x approaches 2 of kx minus 6, take 2 and plug it in for x. And so then I'm going to have k times 2 minus 6, which is 2k minus 6. Okay. So I want the limit from the left to equal the limit from the right. Okay, you got it. So we're going to set 4k equals 2k minus 6. Are we good? Subtract 2k. 2k is negative 6, and k is negative 3.
Or there should be the answer he got. And he just showed me the 3, and I said, nope, He looks at me, I said -3, so he put his other finger up there.
So k is -3. Now, what are we doing? We're finding the value of k that is continuous. So k equals -3 is going to make the limit from the left equal the limit from the right, yes? What's the other piece I have to be concerned about?
Is it a whole or
Well, we're making sure there's no hole or asymptote, right? So if I put the -3, but here's the deal. -3 is going to go in where, or excuse me, forget that for a moment. Limit from the left equaling the limit from the right.
Yes.
And then we also want to make sure the function equals that same thing at 2. Well, at 2, x less than or equal to 2, isn't that going to happen right here? And isn't that where kx squared is? Which we've already talked about, isn't it? So it's going to end up being the same there. So how do I have this stated? Okay. That's what I did. So what is the limit? I did go ahead and find the limit and the point. This is what I was looking back to see how I'd done this in my notes. The limit as x approaches 2 of g of x is going to be what?
-12.
Because you take 2 and you put it in, which means you're putting it in right here, yes? And then what else do we know? We just found k is -3, yes? So when x is 2 and k is -3, we get -12. So that's the limit. And what is g of 2 then? And again, g of 2, that's plug in 2, plug in the -3. That also equals the same, doesn't it? Because you're plugging into the same thing. Therefore, yeah. And we can say if k equals -3, then the limit as x approaches 2 of g of x is equal to g of 2. And I'm going to say, therefore, continuous. I have basically the same stuff in my notes. That's what I was checking. Okay. We're getting the basics there of what we're just really delving into definition of continuity. Understanding all the pieces. Some of this is repetitive, but it's still good to look at. You ready for B? What do we need to consider? We're trying to find what that k value is going to be. So, limit from the left and right of what value? 4. So limit from the left of 4. Which equation am I using there? The absolute value of x minus 4 over x minus 4. Yeah, essentially because if you recall, this is the one where we can really just say the x minus 4's cancel, yes?
Yep.
And actually, though,
It'd be -1.
it'd be negative, right?
She said -1.
Okay, did you? Okay. Sorry, I spaced it. In my brain, I hadn't gotten there yet, so. The x minus 4's cancel. Why did we have to say negative?
Because the absolute value.
The absolute value, we're approaching 4 from the left. So that means you think about your v, it's going to have a -1 slope there, isn't it?
Yeah.
So that's -1. Now, the limit as x approaches 4 from the right is using 5k minus 4x. If we plug that in, we end up with
5k minus 16.
5k minus 4 times 4, which is 5k minus 16. How do I find k? The limit from the left needs to equal the limit from the right. So 5k minus 16 equals -1. Oh, that does work out nicely, doesn't it? My brain was getting 17. Just don't ask. Okay.
K equals 3.
I was still coming up with 17/5. I was like, oh, is this really what it's supposed to do? Not that it can't, but yeah, my notes agree.
Finally, remember my least favorite part of pre-calc.
Huh?
Absolute value.
Well,
Gosh, I hated those.
okay, guys.
Absolute values are repeats, right?
The limit as x approaches, what are we doing? 4 of h of x. Well, as x approaches 4, we're using this definition, yes? And, oh wait, well, it's -1 here, and what would it be here?
-1.
5 times 3 is -16, so that is -1 as well. So the limit equals -1. And what does h of 4 equal? This is where I need to be. 5 times the 3 is 15, minus 4 times the 4, and so that is also -1. So we know, yeah, it is continuous. H of x is continuous. When k equals, what was k? 3. Since the limit as x approaches 4 of h of x is equal to h of 4. And I've written a couple of these different ways, but it's just making sure you have all the information here. Okay. Ready to look at 5?
Yeah.
Kind of?
Kind
Okay. Okay, given h of x, for what values of x is h of x not continuous? Okay, now, as you look at each of these individuals, -2x minus 5, is that continuous on its own?
Yeah.
It's a line, yes? Or remember we talked yesterday, it's a polynomial?
Mhm.
Polynomial, it's going to be continuous. 3, is that continuous?
Yeah. It could just be
What
a
is
straight
it?
line.
It's a
Or vertical.
straight line this way. Okay.
Horizontal line, not vertical.
X cubed minus 6x plus 3, is that continuous?
Yeah.
Yeah, it's some kind of cubic, right? Again, they're all polynomials, so because of that, each piece is continuous. And that's a good thing to start off checking, because if we have weird things that aren't, then we have to take that into account. So I'm going to make a note here that each piece is continuous, since polynomials are continuous everywhere. Okay, just good thought to have.
I do have a good question.
Uh-huh.
What would something be that's not continuous? Like, in
like-
this first stage.
Like, so if you have a fraction, for instance, wrong piece, where was, like these. We can't assume those are continuous because there's a fraction that has denominators.
Okay.
Things like exponential functions and log function stuff, they're continuous on their domain, but they don't exist everywhere. Just you throw in some trig functions. They're not going to be, like tangent, cotangent. They're not going to be continuous everywhere. So just various things. But polynomials, like just the numerator here, that's continuous. Like if you're looking at just any type of adding and subtracting terms added, anytime you get x in a denominator though, it's not going to be continuous. Okay. Now, as we think about justifying, we're looking for something not being continuous, right? So we've got to consider the point. Let's see. So h of, what point should I talk about here, do you think?
-2.
-2. Because if each of these pieces are continuous, our big concern is where they all come together, right? Where they meet or don't meet. What do you know about h of negative 2?
3.
It is defined to be 3, yes? Okay. Shall we talk about some limits? The limit as x approaches negative 2 from the left, which means I'm using which piece?
Negative 2x minus
When x is less than negative 2. So I'm using negative 2x minus 5, which is going to be
negative 1.
Negative 1. Whoops.
4 minus 5, negative 1. The limit as x approaches negative 2 from the right.
That'll be the x cubed minus 6x.
So that's when x is greater than negative 2. So x cubed minus 6x plus 3
That's 7.
Is negative 2 cubed negative?
No,
Yes.
Yes.
Yeah,
it'd
no,
be
that's
negative.
Okay. So
It's negative
Negative
2
Multiply
17.
two
plus
negatives.
12 plus 3, which should be 7.
I can agree with the 7.
It's 7.
That is what I got.
7.
Took me a minute, but I got
So because of this, what do we know right here?
Not continuous. Or it's not- Yeah.
The limit as x approaches negative 2 of h of x, well, that limit does not exist, does it? Okay. And on top of that,
It's under,
it doesn't equal that point either, does it?
Yeah.
So the limit as x approaches negative 2 of h of x does not equal h of negative 2. So all of those are reasons to say it is not continuous at x equals negative 2. And it just said for what values of x. So there's only one answer here. And we can justify that because each of the other pieces were just nice continuous. We had a line, we had a cubic, we had a line. Okay. Now, I have a graph sketched in my, but
Is our work good enough justification?
But we just
Or
did.
is that?
what do you mean?
What's it like justify? So is the limit of x as approaching negative 2, h of x does not equal h of negative 2? Is that the justification?
Like if we would have said the limit from the left does not equal the limit from the right. Officially, you should then draw a statement that states they're not equal to each other.
Oh, okay, which we did
Which
right above with the limit. Does not,
I said the limit does not exist, so
and then you said the limit does not equal the.
the point, right?
Okay.
Okay. 6. Use the 3-part definition of continuity to create a system of equations and find the values of a and b so that f of x is continuous for all real numbers. Well, continuous for all real numbers, what's going to be the key point here? We're going to have to consider and make sure that we are continuous at
6.
Negative
negative 1.
Same thing.
No.
They're both in the
No.
same
Shut up.
column.
Just stop.
Okay. We're going to make sure they're continuous at negative 1. So we're going to start there.
I'm very scared. Yeah, it's not-
I'm going to start with the limit as x approaches negative 1 from the left. Which one am I using for negative 1 from the left?
2ax minus
2ax minus b. If I take that limit and plug the negative 1 in,
you get negative 2a minus b.
are we there? Because it said to create a system of equations, right? Here's one equation. Now, the limit as x approaches negative 1 from the right. So now I'm looking when x is greater than negative 1, and so now we're using ax squared plus b. Plug in the negative 1.
Negative x squared.
A plus.
A plus B.
What?
The negative 1 is going in for x, not a.
Oh, yeah.
I can't say anything because I am so guilty of making that mistake.
There are so many letters right now. I'm like,
Even
which
I
one?
got that one.
Okay, now we have a system of equations. Okay, we can also find. What did I do here?
Could you not? Could you not find it for this?
Where did I? Oh, okay. There we go.
Oh, you can find it for this.
The limit from the left needs to equal the limit from the right, yes?
Yeah.
But here's the other thing. What do these limits need to equal?
Each other.
Each other, but if we are saying that this is continuous,
S equals 6.
yes?
It has to equal the value of
Because what is f of -1 going to be?
6.
It's going to equal 6.
Right.
So the idea here we can do here is that each of these equations, we need these limits to equal 6, don't they? Yeah. Okay, so now I just wrote a system. So this right here, guys. This right here. System of equations, yes? Negative 2a minus b equals 6, and a plus b equals 6. Can we solve? Can we go back to our algebra days?
Yes, 2 equals A.
You can't use
A equals 2. A equals 9. A equals 2.
Sure.
You sound like you're having a stroke.
For what?
I don't know. Okay, so
And B equals
if I just eliminate,
Oh, wait.
Oh.
if I just add because my b's are already set up to eliminate when I add here. Negative 2a plus a is negative a. Negative b plus b is gone. 6 plus 6 is 12. Negative a is 12, so that means a is negative 12.
So wrong. I was getting there. I was working it through my head, and I was like, that's not going to be right.
In order to find b, instead of a, I can say negative 12 plus b equals 6. And so b is going to be
-6.
18?
I had 18.
Yeah, yeah, in mine.
Are we good?
It just makes my head hurt.
Because
Let's go to the next
you
question,
subtracted a
though.
negative, so you added it.
Okay,
I just
Now.
calculated.
that's the thing. We have to do this without the calculator. Find the values of a and b so that f of x is continuous for all real numbers. Right there, folks.
You just
A is negative 12, b is 18. We could go through if I wanted to take more time and write out the limit from the left, limit from the right, all that.
Really okay.
Moving on. Okay, because I want to look at the bottom real quick. You know that the function value and limit value can exist independently of each other. Let's summarize the big ideas of continuity on intervals at points and one-sided limits. So, 7 real quick. Given g of x, find each of the following. As x approaches 3 from the left of g of x, what is that limit?
7.
yes.
7 makes sense. Sure.
Yes, it is.
The left, x is less than 3. Okay. The limit as x approaches 3 from the right.
9.
9.
9.
Okay.
Oh, 9.
Here we're using x squared. So I'm going with 9. Are we good with that one?
Yes.
Okay. G of 3.
9.
Wait, what?
No, how do you get that?
Because
Where do you plug 3 in? Where is it defined for 3?
greater than or equal to.
Greater than or equal to 3.
Okay.
So again, we're doing the 3 squared, which is 9. The limit as x approaches 3 of g of x,
Daniel,
because
they do not.
left and right do not agree. Is g of x continuous at x equals 3?
No.
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 Those limits do not.
Yeah, and right there it's the limit as x approaches 3 from the left of g of x is what I'm working with, does not equal the limit as x approaches 3 from the right of g of x. Okay? Okay,
My head hurts.
we got through it.
Just to go to anatomy.
First time in a long time.
Whoa.
Okay, your job is 1.6 homework for tomorrow. Okay,
All 4 pages of it.
yeah.
1, 2.
No.
Yep.
Only 3
That's awful.
All of it.
Couldn't agree more.
I mean, probably you don't have to do it, but